Hello, friends. Welcome to a special ATC Double Cut. I have two guests joining, repeat guests on the show. It is Bjarni Hannesson from Iceland and Jason Haines from Canada. Welcome, gentlemen.
Thank you.
Thanks for having us.
And this is not only a special ATC Double Cut for having guests, but it is the very first of a potential continuing sub-series that I think would be fun and funny at the same time. How about a podcast about turfgrass math? And we've all talked about numbers before and spreadsheets and calculations that we make. And I thought it would be fun if we sometimes have Jason and Bjarni on the show, maybe together, but sometimes because of busy schedules, maybe only one can join us. And we talk about some turfgrass math related issues. So, how to do it when we have
and math. That's the best mix ever.
I think so. And I guess my idea for this is that we are not mathematicians. I used to be a golf course superintendent. You both are golf course superintendents. We're not mathematicians, but sometimes we find numbers or calculations or statistics useful in the work. And I guess we've all learned by trial and error and study and intuition about how some of these can be applied to make better turfgrass conditions. And I want to share some of that, what I've learned. And I think you guys have all learned things and would like to share too. So I thought we could get together and do that. What is that kind of your idea also, Jason?
Yeah, it's, math has been a big important tool for me, especially in the last 10 years. And I think it's just kind of cool to be able to talk about it and just so that everybody else knows just all the different ways that you can use it to optimize what we're doing.
Yeah, definitely. And moving away from when I started in the industry, and you were talking about bags per something, put a bag of this to that. You're like, what does that mean? To nowadays, where we have everything pretty much dialed in, we know the numbers, and it's been a bit of a journey in that sense. But then again, math used to be my strong point in school. I'm a big joke around the Icelandic greenkeeping circuits because I can't spell, but I can do very complicated numbers. So my mind works in the mathematic way, and that's why I like the mathematics of the whole thing. And they're kind of important also. To a point where you're always getting on, Micah, is we need to have numbers that we can relate between, so we can understand each other what we're talking about. Because if I call a British greenkeeper and he tells me he's using a half rate of fertilizer, and you're like, well, that's great. Half of what?
Yeah. And so I know that you both started new positions as head greenkeepers or golf course superintendents at new courses this year. And I think it seems to me that being familiar with some of the numbers that are related to fertilizer rates and growth rates and the things that are associated with how much the grass grows, maybe how much sand you might put or how often you might mow or something, could be useful when you move all the way from British Columbia to which province are you in now, Jason?
Nova Scotia.
Nova Scotia. So that's, what is that, 5,000 kilometers?
About that. It's from one end of the continent to the other. Yeah.
And you also change grasses, right? So now you're on a primarily fine fescue property, and previously you'd been on a ryegrass, boa annua, bentgrass, yarrow type of property, right?
Yeah, exactly. Yeah. So, pretty big changes from one place to the other. And, having, my background with the data that I can collect and tools that I can use has really been important to make that as seamless as possible. To help me get it right the first time instead of taking 5 years for me to figure out what I'm doing, because there's a lot of things that are different about here versus where I've been in the past.
How about you, Bjarni? You went across town, maybe up a couple meters in elevation. But have you noticed that do some of the numbers, the clipping volume, for example, is it useful to have that as a technique when you move from one property to a new one?
Yeah, it's been very helpful for me because I've been busy on construction on one of the courses, so I've been very tied up in the construction process of it, which just having those numbers, being able to look at them, I can more comfortably just set my course managers into what to do, and then I can comfortably Otherwise, I would be spending way more time monitoring things. There's a cat here invading this podcast. There you go. Sorry about that.
Catch the video if you want to see the cat.
Yeah, you have to get the through. Yeah. So it just makes me more comfortable sort of focusing. I know what's going on at the course. I can monitor, I can look at the numbers, go out to the course quickly, just, to issue, make sure my eyes are seeing what the numbers are seeing. And then if I didn't have that, I would be spending way more time out, guessing a little bit, way more time getting it wrong, I think. But it's definitely interesting moving, because we've been moving grass species a little bit, because we were heavy POA on the last property. We're now on more fescue based sorts, so just different numbers, but you get used to them.
I bet you've been getting used to some different numbers, Jason, with moving from the traditional type of POA bentgrass surfaces from the Pacific Northwest to mostly fescue. What's the big difference? I mean, I know this is a turf math podcast. We're going to get to that. We'll get to more of the math, but tell me a little bit about the grass. I've been curious to ask you about what fescue's like.
Well, first off, I just want to say that with the fescue, like this course that I'm at, it was designed for fescue. So we have massive greens. We have 2 hectares of greens. Our biggest green has more grass. We have a single green that has more grass than my first golf course had combined for all the putting surfaces. So really big greens, but even despite that, I've never spent less on fertilizer or chemicals, or we've never applied less water. Now the weather has helped us this year, but it's been pretty, I would say, minimalistic, which is what this place is designed for. But for fertilizer, right now we're at 2.5 grams per square meter, which is less than a pound, 0.6 of a pound.
That's about half a pound per 1,000 square feet.
Yeah, and we're putting 200 to 250 rounds a day, about 180 to 200 golfers plus caddies. And again, because the greens are designed to be massive, we can spread that traffic. And so that's been quite interesting to see how little it needs. Obviously, our growth rates are much lower than when we had POA. So if you're familiar with the growth ratio, I would with POA, I would try to maintain it at 80%. And here our number is 30%. So it's less than half. When we get down to 20%, you start to see the grass struggle a little bit. So that's been a huge tool for me that we could talk about at a later date in more depth, and we've already discussed it on this podcast before. Water is crazy because we have 8 to 10 inch roots in our putting greens. We're cutting at I don't have the metric height, 190 thousandths. We have 8 to 10 inch roots. We can get, with the longest times on our moisture meters, down to 2% moisture, the MC, before we start seeing wilt. Our magic number is probably 4%. They like to see the grass brown here. And we haven't been able to do that this year because of never ending rain. But But we have got the greens really dry, and they spring right back, no problem. Where with the POA, I was, more around 20%. And what else? We have clippings, fertilizer, water. I mean, those are the biggest differences. Oh yeah, and no fungicide, nothing this year. So that's also
That's nice. Well,
completely different from what I'm used to.
Okay. I've just messed up my video somehow, which is just wait a second. Oh my. That's really interesting. Can you hear me?
Yeah.
All right. So you can hear me. Oh my. What am I doing? Well, it's good because more people listen to this than watch it anyway. But
That's a shame because the cat came in there, stole the show.
yeah, well, we're going to continue with this because I don't really edit these very much. And as long as we've got the audio, I can just take my picture out of this, and I've got guests, and we can talk about the lovely blog post. So since this is an ATC double cut, let's Jason, I want to talk with you about the growth ratio and these things at the end of the season. And I will be really interested to hear about that in detail. Let's look at one of the blog posts that I'll put a direct link to in the show notes, and that is on the seductive attractions of metric units, which is a blog post that I wrote many years ago, and I updated it a couple years ago. And I'm seeing this on my screen. I think if you're watching this on YouTube, you should be able to see this. The direct link will be in the show notes. And if you're listening to it, I'll describe it to you. I start off by saying that I grew up in the United States using U.S. customary units, and I started to use metric units when I went to work as a golf course superintendent in China and Japan, and I have been using these units ever since. And I like to use the square meter as a base unit. So let's talk a little bit about the square meter and some of the things that we can just make these calculations on the fly so easily. I guess, Jason, you grew up in a bit of a hybrid system, didn't you? And then Bjarni, you would have been pure metric.
I'm a purebred metriconian. So I don't know what. Yeah.
Yeah, we were. I mean, in Canada, I'm born in '85, so everything from that point was all metric taught. But everybody that's older than me, or 10, 15 years older than me, my parents' age, 20 years older, they were not taught metric. So we're kind of in a transition phase where I think my kids will probably be mostly metric.
Okay. So a square meter is 10.76 square feet. So it's about like 1 square yard, basically. A square meter is about, if you take one step in one direction and then you take a 90-degree angle and take one step in the other direction, you've just covered 2 sides of 1 square meter. And it's a very comfortable type of space for me, or a very comfortable type of area. And so I like to use that as the base unit rather than, like, 1,000 square feet is, I think, kind of the base unit that Americans often use for putting greens. And then around the world for metric, for agriculture, it's common to use a hectare. Now, I prefer to use a square meter myself because, as I said, it's like 1 square yard, basically. You can see it in front of you. I can't see an entire hectare. Maybe if I was in an airplane or a satellite or a drone, I could see a hectare, but it's harder for me to imagine a hectare. And then 1,000 square feet is just sort of like a convenience unit. But if you have a putting green, it's going to be like 4,280 square feet or 6,000 or where you are, Jason, maybe 20,000 square feet.
35,000.
Wow. So I like to use a square meter as the base unit.
Can I say that one thing about the good thing about Hector is that a lot of golf courses for 18 holes have putting greens roughly, if you total them, that's 1 hectare. That's often that way. Saying that I'm on a golf course and you, Jason, are not both on golf courses that have unusually large greens, because I have 1.6 hectares or 16,000 square meters. But that's just when in the golf, when you're dealing with greens, that's why I often switch to hectares for something, because it gives you an idea of how much you're applying to all your greens. That's why I sometimes jump between hectares and square meters. But the good thing, though, is that you can't do that. It's the same numbers. It's just you're moving the decimal places. So
Yeah,
that's the good thing.
you can definitely do that, and you're just changing the square meter. I mean, you're just changing the decimal points. So it's
because pound per thousand, and you switch it over to pounds per acre, become different numbers. Totally right. You should know I'm not.
Yeah, it's not on the same level. So it's 40. There's 43.56 thousand square feet in 1 acre. So I believe an acre is 43,560 square feet, and so it's not. You have to remember a lot of things of here's what the conversion factor is if you're going from 1,000 square feet to acres, whereas with square meters to hectares, you just know it's a factor of 10,000 different, and so that's easier once you get accustomed to it. What else do we have in this blog post? So I start off. Let's see. I said first I can see 1 square meter. I can imagine it, and I can think of how that base unit will be managed. Then it is simply a matter of considering how many of those base units of 1 square meter are to be managed. And then the second point is that the numbers work out in a convenient way in 3-dimensional space. And I elaborate on the convenience of this below. And what I'm getting at there is that it is wonderful to, with the metric system, with the way that volume is related to distance. And so when you've got 1 cubic centimeter, so 1 centimeter is 1/100th, or it's 1/100th of a meter. And if you take a cubic centimeter, that is now we're in volume. And if we take 1,000 of those, now we have a liter, which is a convenient amount of volume. And they're all linked together in a way that turns out to be incredibly convenient when we start talking about irrigation, soil water content, clipping volume, and things like that.
Yeah, you can move so easily between everything. I remember reading irrigation design books back in the day, and even volume was like ridiculous calculations with all sorts of stuff. And then below, they did it in the metrics, and it was like they used about a third of the ink they used to print the other stuff. So it's just the fact that you can move between distances and into volume is a key thing for a lot of things that we do, like irrigation and stuff like that. And you can even shift that into pressure, because if you take it from pressure, I mean, 1 bar is the equivalent of a column, 10-meter high column of water, pretty much. So that's why we often talk about meter head pressure. So you can move from pressure, distance, you know what I mean? It's just that's so easy to use it.
That's something that I don't know how to do, but that is the beauty of using these type of units. Is there's a lot of things that they're all related in a very, very convenient way. So let's see.
Well, with the water, I mean, it's super easy with the moisture meter, because it gives you a percentage. And I know it'd be another good talk to spend a little bit more in depth on is visualizing or estimating how much water you need to apply. If you have, like for me, if I have 5% moisture and I want to bring it to 10, in the top 10 centimeters, I need to apply 10 millimeters or 5 millimeters of water. So it's all pretty easy because that percentage works out pretty nice that way. So it makes it super easy for irrigation. Like, it's ridiculous how easy it is. Like, I don't even need to do the math. It's in your head.
Right. So you need to apply 5 liters of water per square meter to apply that. So you look at the ET rates. So the ET rate might be 4 millimeters of water per day, and you can then know that you need to apply 4 liters of water per square meter. So and that's going to increase.
Or 4 millimeters or 4 millimeters to supply over that square meter is the same amount of water.
Or 4 millimeters, and that's going to increase your soil water content in the 10 centimeter depth of the root zone by 4%. And that's something that is, I think that is so useful that it's worth using the metric system for water just for that purpose if you're involved in professional turfgrass management.
Yeah, especially now that we have moisture meters. I mean, it just, because I'm not, I mean, I use the ET, the theoretical number, kind of as a base number, but ultimately we go out, we test it, and we know exactly what the moisture is, and we know what, if we want to bring it to, how many millimeters, if our irrigation systems are calibrated appropriately, we need to add. So it's super easy to just really dial it in. And I mean, I haven't used my irrigation system this year, but which we're in, early August here, which is kind of crazy. But at my previous golf course, we could maintain our soil moisture within a few percentage points for weeks at a time, exactly day after day. And that was just simply by measuring the moisture and understanding how much water we needed to add to replace what we were seeing with our moisture meters.
It's all stuff you can do with imperial numbers, but it just means you need to use different types. You have to transform the percentage into what it is in imperial. That's a different number. Whilst in this case, you're just using the same numbers, like 5% actually turns into 5 mil, which is 5 liters per square meter. So you're always using the same number, which I think is a very good reason just to pick it up. Because using all these numbers. Another thing that bothers me too about imperial, and you have to tell me if I'm mad or not, but why they always speak about when you get less than an inch of anything. We talk about ET rates and less than an inch, but they always use fractions. So it's like 3/16, 1/8. And in my head, it's sometimes so illogical because sometimes you end up with having larger numbers. What I mean by that is like, picking out of my head here. So you can have larger numbers, but they're smaller. As in, give me an example of this. This is what, 3/16, and then you got. See, I can't do the. What I mean?
You get into 30 seconds of an inch, right? It's a bigger,
or
bigger number.
12/64 or something.
Yeah. So in my head, I'm always like, if someone, give me the Allen key of this size, and then says, oh no, actually I need to go, can you give me this? And I'm like, is he asking for a bigger Allen key or a small? You have to do the math a little bit. I know it doesn't take a long time. And if you're used to the imperial, you probably visualize that in your head. But it's still illogical. To me, it doesn't make any sense why don't you have a smaller number than an inch, if you know what I mean? Instead of saying always 0.368 of an inch.
Well,
I mean,
go ahead. I agree with you about all of this, but I recognize that people that are familiar with the U.S. Customary units are going to continue using them. So I guess if we can share some of the turf hacks, like, okay, with the metric system, it's so easy with the water, for example. I'm sure some people, especially younger people, if you're just getting into the business and you think you're going to be working in turfgrass for the next 10, 15, 20, 30, 40 years, you're young enough to say, let's take advantage of some of these cool things and make it easier and really get precise with the irrigation management and be able to just make all these calculations in your head as you're going around. You don't even have to think about it. It just gets like second nature. And I know everybody does that in their own language, right? Their own thinking language or their own units that they're familiar with. But there's no way that you can get the exact number so quickly as you can if you're doing what we just talked about. I don't think.
No, and but it's tough for a lot of people if you're mentoring under in Europe it's different, but in Canada, if you're mentoring under a superintendent who still is imperial, for me, I started doing metric when I became a superintendent, and I was trying to make more sense of my records because my fertilizer records weren't really telling me much other than what I applied on what date, but I wanted like nutrient rates broken down by month and all these other things. So that's when I made the switch. I think it was like 2000 and probably 8 or 9, a couple years after I became a superintendent, where I was like, I'm just going to make the switch to metric. And then, so I've been for fertilizer and for water, I've been metric since then, for the most part. I think we're seeing a slow conversion with superintendents in the United States, particularly those who are using clip fall, where they're switching to milliliters per square meter.
Now I want to go back to that. I started off using 100 square meters as the base unit because then you often have a full liter or 2 liters because you're getting 10 milliliters per square meter or 20 milliliters per square meter, and I learned about this in Japan at a golf course that was using 100 square meters as the base area. And so we were looking at numbers that were 1 or 2 liters. And I knew some other people were using milliliters per square meter. And then finally I realized, man, if we use a square meter as the base unit, now we don't have to worry about whether our clipping volume was 0.6, 0.7, 1.2 liters per 100. We can just say it was 6, 7, 12. And when I did that, when I started using those type of units, I remember talking with you, Bjarni, and you said, you know what, Micah, I kind of like 100 square meters, and I like working with the liters, and you were familiar with like what 100 square meters is. What are you thinking now? Have you come around to my way of thinking where we're on integer values from 1 to 100, or have you persistently stuck with what I now think was a mistaken introduction of units on my behalf back in 2014, 2015?
Yeah. Well, here's the thing. I've been switching now into the milliliters per square meter because I help other guys out with setting up their clipboards and stuff, and help them out with understanding it. And I've decided to let's use the hopefully universal number of milliliters per square meter. But what I found now is that for the staff that's in the field, when you're trying to explain to them these numbers, they don't relate to them very much. Technically speaking, they don't need to. They just need to report back what it is. But I always like my staff to know as much as possible. I'm one of those guys that's very annoying, constantly talking turf to my staff. But you might inspire some of them. But so what I found that using liters per 100, they could relate more to it because they are actually measuring in liters. So they take a middle bucket off, put it into the measurement, and they see there are 2 liters in the bucket or 3 liters in the bucket. And when you tell them, if you divide that by the size of that green, that's roughly 1.2 liters. And that visually makes more sense to them. When I talk to them about 12 mil per square, that seems to be a number that, they don't seem to pick up on it. So I tend to switch when I'm speaking to people, like, am I talking about liters per 100 or whatever? But when I'm recording it now, I do it in the milliliters per 100. But then again, it's easy to shift because you're just moving that decimal, that point, shifting it.
I just sent an email before we recorded this to a golf course superintendent in the United States who I am happy to report was communicating to me about clipping volume in liters per 100 square meters. So here it's an American superintendent using full-on metric, which was awesome. And I converted myself to milliliters per square meter, and it's just natural. It's just like it's very easy to do.
It doesn't take a lot of brain power for me to switch.
No, the
Just-
factor
and
of,
I agree. It is easier to say 8
yep.
than 0.8. So yeah,
Yeah.
I'll agree to that.
And
Definitely.
also I find in communicating with staff, we can also, because generally we might be familiar with the property, so we might know that this green, typically we get like 12, let's say we get 10 liters from this green. So, you know, if you're getting more than 10 liters from this green, it's growing a lot. If you're getting less than 10 liters from this green, it's not growing very much. So in communicating with the staff, we can just talk about those units if we're familiar with the property. But
Yeah.
then for communicating with others, or for adding things up over the course of a year, comparing green to green and so on, we need to standardize it. And when I standardize it, I like to standardize with milliliters per square meter.
That's one thing we do is we have in our lunchroom where my staff will write down what they collected. We have all the holes on one side and we have the dates, and so it's just liters total.
Mm-hmm.
It's not converted at all. I do the conversion in a spreadsheet, but they could see from one mowing to the next if the growth rate is high or low. I've had people telling me that they think there's something wrong with their mower because they're not collecting any grass. Turns out they were on the T mower, things like that. So well, it's good, right? They figured it out after a green, where normally they would have probably just went and cut 18 greens and done nothing, and then realized at the end, oh, I didn't get any grass because the baskets weren't filling up. So they're a little bit more aware of that. I mean, and it's also like with clippings, it's also kind of convenient. 10 milliliters per square meter for most grasses, not including fescue, but for bentgrass and poa, is kind of a good number.
Mm-hmm.
If you're getting that much per day, you're probably doing pretty good. Now I'm less than half of that right now, but for everybody else, like it's a nice, easy number.
So were you telling
higher
me,
than 10, you're probably fast.
Jason, were you saying that the growth ratio that you've found that's working good this year on fescue that's getting 200 rounds or something a day or more, of a growth ratio of about 0.3 is working great?
It's perfect. Right now, we're actually down the weeklies at 0.2 and our monthlies at 0.27. And I'm just, when I go out there and look at the greens, I'm like, they could probably use, half a gram of nitrogen per square meter, which
is
for fertilizer, the units I use is half a gram and 1 gram,
mm-hmm.
which converts to half a gram is about a tenth of a pound, and 1 gram is about a quarter pound. These are the, have a light rate or a heavy rate. And so that's also kind of convenient if you're doing a really rough conversion from one to the other. And then it works out basically like 1 bag of urea, like a 25 kilogram bag of urea on 1 hectare is 1 gram per square meter. And then I go out with like a ammonium sulfate, and it's about 0.4 grams per hectare. It doesn't really matter if you get it 0.5 exactly, whatever. There's a light rate as a bag of ammonium sulfate, a little bit heavier rate as a bag of urea. For me, with massive greens, it's even easier to get light rates because I could put 1 bag of urea on 2 hectares quite easily. I don't like mixing bags or measuring. I just dump a whole bag. So a whole bag or nothing.
Yeah, you don't like measuring, and I've talked with some other golf course superintendents who also don't like measuring. They just like to use bags. I like to be a little bit more precise, and I don't understand why we can't just measure, but I leave it to the professionals who do this every day to choose the way that works for them. Jason, you said that at this time you may need to get back to work. So that may be a good point for me and Bjarni to continue the conversation and us to say goodbye. And please join us again for a future Turf Math edition of the ATC Double Cut. And also, let's review the year at the end of the year. And I'm really interested to learn what I'd like to learn from you what you've learned this year in a different grass and a complete other side of the country, different climate.
Yeah, thanks for having me. Two of my favorite topics, grass and math. And yeah, I look forward to sharing more. It's kind of cool with this data to be able to collect it, to be able to learn something so quickly, and then hopefully be able to share what I learned.
Yeah,
Where if I wasn't collecting it, I'd really have nothing intelligent to say at the end of the season. So.
yeah. Well, maybe you can join us. We can do a live stream and have a spreadsheet and just imagine how exciting that could be.
Oh my God, I have all the spreadsheets. It's pretty sweet.
If anybody hasn't seen it yet, I have a video on the ATC YouTube channel where I had a chance to visit Jason at the Sunshine Coast Golf and Country Club in British Columbia a few weeks or a month or so before he departed. And I got a chance to go to the control room where it all happens and see all those spreadsheets. We also went out on the course and looked at some frost and ball roll and shade issues, all kinds of cool things. So check out that video if you'd like to see where Jason was prior to his current position in Nova Scotia. All right, Jason, thank you for joining us, and have a good day.
See you guys later.
See you.
Bye.
Bye.
Okay. Well,
I can get comment a little bit on the full back approach that he's going for there.
Please, I've got a note. I've got a note that I've had conversations with 3 superintendents who've told me that they just do it this way, which to me seems really crude. And I've got a note like, okay, I want to blog about it. So I'm so interested to hear from you. Please tell me.
Here's the thing. Like I said before, like often you're dealing with greens that are on 18 holes. They're roughly about 1 hectare or 100 meters by 100 meters, which is 10,000 square meters. Now, so if you take a bag of ammonium sulfate, which includes 21% nitrogen, in that bag you have about 5.25 kilograms of nitrogen, or 5. If you put a full bag of that into your tank and you spray it, you're going to get a little bit of color, not a massive amount of growth, and that's going to work out to be like close to 5 kilograms per hectare or 0.5 grams per square meter. So if your greens are roughly in that hectare range, that's a very convenient product to just throw straight in the tank, and you're close enough to the 5K or 0.5 gram mark that you're trying to go for. And urea works out to be about 46% in a 25K bag is about 11.3 kilograms. So that's roughly about 10 a single gram per hectare on most of your greens. So you're quite close by just, if you want to get a little more growth kick, full bag of urea. If you want to get ammonium sulfate in, full bag of ammonium sulfate. Saying that, I measure all my stuff out and I try to be hitting a target, and the guys are opening a bag and putting like 2K out of that bag into the tank. And,
so I appreciate that explanation. The part that I don't understand, I guess, is I want my rate. I want my application rate to be continuous, meaning it's a continuous variable that sometimes it's going to be 0, sometimes it's going to be 1. Now, I'm not talking about any units here. I'm just saying it's a continuous number that sometimes is 0, sometimes it's 1, sometimes it's 2, sometimes it's 3, sometimes it's 4. And you're saying our rates could only be 0, 0.5, or 1. And I'm saying I want it to be every possible number from 0 up to 1. It could be zeros, or now I'm going to express on a scale of 0 to 100. So the maximum rate would be 100, and I want it to be any possible rate. So I know Jason's talked about okay, if I want the grass to grow faster, I'm going to put some fertilizer. If I don't want it to grow faster, I'm going to not put fertilizer. And maybe it is that simple, but I often think sometimes I want to put 0.42 grams to get just the desired growth rate. And I don't want to put 0.5. I want to put 0.42. So for me to do that, I need to measure and not just say, okay, I'm going to choose ammonium sulfate this time, and 1 bag is going to be close enough.
Yeah, I do the measurement myself. I do, I want to get this as accurate as I possibly can, but I can see the convenience when some guys are looking at it and it's like, okay, I'm gonna get 5 or I'm gonna get 5.83. In the end of the day, that's going to be a huge difference on playability. Um, and it's just one bag out of, instead of putting a bag in there with 2K of ammonium sulfate in it out of the 25, it's just quick and easy, ripping it, throwing it in. I guess that's what the idea is, that the difference between, 5 or 5.6, or sorry, 0.5 or 0.56 grams per square
Mhm.
meter, they might not see it as being that important, playability wise.
Yeah, I suppose that is the case. That it,
Yeah.
yeah, in the end, it may not matter so much if you can get pretty close, but you're still like, if you're just flipping between. So we're talking about rates of whether you're putting down a tenth of a pound or 2/10 of a pound, and
Yeah.
so I apologize to those who would really rather we talk in those units. So
Mhm.
I'll talk about those units for a moment. So we're talking about whether you put 0 or whether you put down a 20th of a pound or whether you put down a tenth of a pound or 2/10 of a pound. Now, shouldn't we sometimes be putting down something in between? Like, and and
Yes.
and so for me, I know people talk about the grass is growing too fast. So you really, I mean, if the grass is growing too fast, probably you want to consider applying nothing.
Hmm.
But definitely, like, you want to cut your rates down. So if a tenth of a pound is too much, you want to put less than a tenth of a pound.
Hmm.
And any anyway, I guess that's for me to do a future blog post, and and I guess, yeah, I guess if you're always under, I don't know. I don't. How much more time does it take to weigh it?
Not much. We've got this scale set up quite simple. You just throw it in the bucket and measure it out and toss it in the sprayer. It doesn't take that much more. I think it's more to do with having a bunch of open bags laying around, and I don't know. It's just, like I say, I do measure the whole thing out. And I agree with you. It's like if I put down 5, it's definitely different putting out zero point 0.5 compared to 0.75 versus
Mm-hmm.
putting out 1. Um, uh, for you in the pound per thousand land, it's it's the 1/20th, 1/15th, and 1/10th, I guess.
Yeah.
Um, I definitely see a difference because I tend to not go for like 1 pound per thousand, especially on greens, going for one that 10 kilograms or 1 gram is definitely something I wouldn't do very much of unless I'm trying to push growth. I'm talking about greens.
1 gram,
Yes.
right? Yeah,
Yeah.
I agree. I think 1 gram, which is 2/10 of a pound of fast release
Mhm.
nitrogen, when you
Yeah.
apply that, the grass sometimes, well, the grass has a chance of responding more than you want. Now we're talking
Yeah.
about golf course putting greens here. I think for
Yeah.
football fields or soccer
Yeah.
fields, that rate is nothing.
Yeah. If you want to push a T or something, then obviously that's not going to be a crazy amount of nitrogen. But I think for greens, I like to be more, you know, small doses and do it more frequently, just looking at the weather and checking on growths and stuff like that. So um, that's why I want to measure it out because I want to know.
Yeah,
I want
I'm.
to know exactly.
Yeah, well, especially when you've got such a short growing season and you need to
Yeah.
make every application count, and you need to take advantage
Mhm.
of the growing weather that you do have. So you never want to be overdoing it. You never want to be underdoing it. So
Yeah.
yeah. So let's see, you're in August. Do you have any frost yet?
No, we've been having. We had the wettest May, wettest June, and then the driest July. It's been very, very strange. We've had 3.3 millimeters of rain in July, and uh, still what we consider great weather. averaging around 12 degrees, which is phenomenal. 12 degrees Celsius, obviously. That
It
is,
just must be like 56 Fahrenheit or something,
yeah.
right? Now,
It's ice
that's not
cream
your
season,
high.
like
That's
I'm
not your
telling you.
high. That's your average,
That's it.
right? So
That's my average for the day. But our average high, I don't think we've broken. We might have broken 20 degrees once for the high, but it's been nice, like 16 degrees, 14 degrees. It's a very nice temperature to grow grass in, and for native-born Icelanders, we're, t-shirts and everything. But
do you
I
wear
don't think
shorts or do you wear trousers?
I'm okay. I'm full trousers, I have to admit. But it's funny walking around town, Reykjavik, here, seeing the tourists with jackets and hats on, and the Icelanders licking ice cream and putting on sunscreen. So we're just used to a little bit of colder temperatures, but it's a good temperature to grow grass. And if you have the grass, we struggled a lot. We had a really tough winter, and a lot of that grass. So
And is
coming back from that is very hard.
so you've put down a lot of seed to replace it, or did you
Yeah,
sod?
we've been seeding a lot. Now we were lucky; we didn't have massive, big areas completely dying, but really massive thinning out, and so we've knocked in a lot of seeds. We've locked in, what was it, about 60 grams per square meter of fescue bent mix. 50, so that's
12.
600 kilograms per
12.
hectare.
Yeah, that's 12 pounds per
I
thousand.
put in almost a metric ton of seed into my greens because they're 1.6 hectares, the greens in total. There's a lot of seed in 3 separate, yeah, roughly about that. And it's just hard to get grass coming back in. That's when you need to push the growth a little bit. That's where your urea back in the tank.
Mm-hmm.
Applying it about close to 10, trying to force things to grow.
But by mid-September, your days are short and your growth potential is down because the temperatures are down. So you've only when you're in early August like this, you're looking at how many more weeks where you'd consider you've got decent growing weather.
It can be. We can sometimes go through the entire August month being fine growing weather, but sometimes it can. By the second, third week, it can start going down a little bit, tapering off a little bit. But September really is when our average temperatures are around 8 to 9 degrees, which slows things down quite a bit. And also, you don't have this. You start to have more darkness, so night temperatures can be a little bit colder. So no, I mean, I've got 2, 3 more weeks of half decent growth, and that's it.
Yeah, it's a short growing season. So good luck to you with all of that seed and getting it to establish it and spread as much as it can before the long winter.
Yeah, I mean, sometimes we can play golf all the way into November, but obviously not great growing conditions. And our golf rounds obviously go down because we have a lot of summer vacations now. We have, I mean, the way we set things up, we have 400 rounds. You can book 400 tee times a day, and there are more rounds than that because that you can play through the night. So on a busy day, we might get 400, 430, 40 rounds, and in 24 hours.
That's
There's a lot of rounds.
It's difficult to do maintenance too when you've got 400 plus rounds that's on an 18 hole basis, right?
Yeah.
So Jason was talking 200, 220 was what they were seeing.
He has caddies as well, so we don't have any caddies. So, but nevertheless, I mean, it's a lot of rounds that we can have, and that's when it comes handy to know what you're applying, nitrogen rates, how much you need to push growth, how much you don't need to push growth. I think that's also one of the key things of monitoring things. Is like when do you not need to do stuff? I think that's a key thing as well.
Yes, we talked before about the nitrogen rates in Iceland, and they seem to be At the first time I went there, the first time we talked was in 2013, and that was just after MLSN had been introduced, and I went and spoke at a Icelandic greenkeepers meeting in September of 2013, and I talked about growth potential and MLSN, and I ran the growth potential numbers, and it says that in Iceland it's so cool that you really should, the growth potential is predicting something like 6 or 7 grams of nitrogen per per square meter, which is about 1.2 pounds of nitrogen per 1,000 square feet per year. And I was informed that it was more common to apply 10 or 12 or 15, I think, if I remember correctly, which seems more like London type numbers or Scotland type numbers. And of course that makes sense if you went and got educated in those places or you did internships in those places. But if you're growing grass in a place that's much cooler and has a shorter growing season, it seems like it's just going to grow less. And maybe we can close with this. Let's just talk about annual nitrogen rate. You mentioned that it's important when you're dealing with a lot of rounds, to make sure that you know what it is. And now, gosh, we're 10 years on from that, Bjarni. That was 2013. This is 2023. What do you think is a good nitrogen rate for a 10-year-old mixed sward putting green in the Reykjavik area?
I think a good starting point is to be somewhere about 80 to 90 kg. That's about 0.8 pound per thousand. So, or 8 to 9 grams per square meter.
Yeah, that's 1 pound, and it's 1.8 pounds, something like that.
Yeah. So it's a good starting point, but it depends a little bit on obviously how busy your golf course is, because not all golf courses are. Well, Reykjavik area is very, very busy, but it's going to depend on that. For example, right now we are at close to 100K nitrogen for this year, but that's because we needed grass to grow quicker, to grow in quicker. It's a bit of a high number, and we'll probably end up in about 110-ish, maybe 150K. So that's more than 2 pounds per thousand. One of the reasons what I thought was like, why are we so high on nitrogens compared to our growth potential and temperature here? I think another thing is that we don't have a lot of our microbial activity is going to be lower here, and we get less help out of the soil, sort of releasing minerals, because it's just microbes operate at a slower pace around here.
Can I interrupt for a moment?
In London. Yeah.
So people in the United States have been talking, because they've been having really high temperatures, and then sometimes a thunderstorm comes through and dumps 50 millimeters or 100 millimeters of rain, saturates the soil. The soil's at field capacity. So now the plant has all the water it can use. The microbes have all the water they can use. And people are seeing these big growth flushes after rain. And you just mentioned that microbial activity, because of the cooler temperatures, is less in Iceland. Do you notice when you get a big rainfall that you get this huge growth response, or is it more subdued in your cooler temperatures?
It's much more subdued, but I definitely see days when it happens that we get maybe 2-3 days. Say our average temperature reaches about 14-15 degrees for 3 days. Given it's not that dry as July was this year, but like given you get a little bit of rain at that point, you definitely see a massive growth kick. Just like boom, it's like it hits you really, really hard. But then when the temperatures drop down again, and our average is at 12 degrees, 11 degrees. That's normal. 11 degrees is that's very low. 10 degrees is 50 Fahrenheit. So we're talking 52, 53, 54. It's just our normal. But once we're closer to the 60s in the Fahrenheit and stuff like that, you definitely see a change in how easy it is to maintain grass at that temperature compared to trying to run your grass at 12 degrees Celsius, 330, 40 rounds every day. It's just, you definitely see the difference when that happens. So I think if we were slightly warmer, well, about 3 degrees on average, this is a tall order to be fair. I think our nitrogen rates would be lower.
Yes, I I had a chance to do some soil tests at your previous property, and I was surprised at how high the organic matter content of the soil was, considering the amount of sand that was being applied. And I speculated, and I think I speculated correctly, that the reason for that is because the grass can grow and produce organic matter in the soil. However, the microbes don't have a long enough active season to really be able to break it down as rapidly as it would if the golf course were at a location that was warmer. So it's like you were double or maybe even a little bit more than double what I would typically see in Tokyo. And Tokyo has a much longer growing season, but it's so hot in Tokyo. Right now the low temperatures in Tokyo are about 27 degrees, and the high temperatures are about 33, 34. So you'll have a soil temperature of about 30, and that breaks down a lot of organic material. That's not happening in Iceland.
I've seen on a golf course here was built on a very pure sand. It was a links course, very, very pure sand. They applied nitrogen, but they weren't growing grass incredibly fast. There was nothing like that. And they had an amazing thatch problem, about 5 centimeters of thatch being built up in 6, 7 years. And it's just very minimal breakdown taking place there. So they needed to start, top dressing way more, punching holes a lot more, and trying to get, control of the area, which they managed to get later on. But just I was impressed by how much thatch was able to build up. But then again, if your soil temperature rarely goes above 12 degrees, then yeah, things are going to be a bit slower.
Well, and you want to make sure that you don't over fertilize in that case where it's not going to break down very much. So I think, that thatch is a sort of a self-imposed problem. If you think the grass wouldn't grow that much if we didn't put fertilizer on it. So that's where some of these numbers, it's like,
That's when just having the clip ball and you be able to measure that and seeing, like, am I growing it silly fast? Am I not growing it silly fast? If our greens are running around 8, 7, maybe 9, 10 per day, milliliters per square meter. That's the clip ball we're dealing with at the moment, which is not high. And given the amount of play we have, it's on the low side, and that's great. We manage to we always can monitor the greens and see if they're thinning out or not thinning out. Are we, but having that measurement is so crucial for us to be able to make sure that we're not making the grass grow too fast, because that leads to thatch issues and having thatch issues in an environment where you don't have a lot of breakdown. We obviously have breakdown, don't get me wrong, but it's just it's not our biggest strength.
Yeah.
Yeah.
So, do you have enough irrigation water? Let's flip over to irrigation. You said July. This was one of the driest Julys. You got 3 millimeters of rain. How much?
3.3 millimeters of rain for the entire month. Saying that our ET rates are running, on a very good day, it's maybe 2.3, 2.4. So it's a slow drought, but it's a drought nevertheless. So we are short by about 60 millimeters of water. Now, where we have, so on the because we have 2 golf courses, one of them, so it was a 9-holer built. They extended and added 18, and made it 18. So on the back 9, we have full irrigation tees and greens. On the front 9, which are yet to be, we're about to go into a project where we're rebuilding them. So currently we only have hose points on the front 9. So this is a year where, if you have a good irrigation system, it's not really a big problem. But where you don't have it, it was a problem. We can run straight off the mains here in Iceland So we're using mains water. Iceland has the highest amount of fresh water per person per capita in the world. And I think the second place runner up has half of what we have.
Are
So
there dams? Where is that water stored in dams? That fresh
no,
water?
it's just it's actually stored in the our lava fields. It's pumped out of the lava fields. This is water
This
that
was
runs
groundwater.
through. Yeah, it's groundwater, and it's interesting because it's run through. Uh, I don't know the English word for it. We could call it basalt. So it's a the pH level of the water that we're actually using is about 9, but it's a very pure water nevertheless. So it's very. It's funny because I had a golf course on the coastline, and sometimes when you had these salty storms, there was such a low EC water that you could notice it. You noticed how poorly it penetrated the surface when you had a layer of salt coming from the ocean on top of it. But we have, like I said, we have abundance of water, so it's not really a problem. This drought through July had no issues on, there was no problem for, there was no limitations to drinking water. We were not asked to reduce irrigation or anything. So it's, I know a lot of other people deal with a lot harder environments when it comes to this than us. We have it quite nice.
Which is one reason to be very knowledgeable about the numbers related to water.
Yeah.
I also know there's a lot of golf course superintendents that still irrigate by time, and they don't know how much water is being applied, and that can be successful. But it's difficult to It's difficult to persuade me that you're doing it in the optimum way if all you can tell me is that you irrigate for 14 minutes.
Yeah.
And I would like to know what your ET is, and I would like to know how much water you applied. And ET is expressed as a depth of water. Precipitation or rainfall is expressed as a depth of water. And I would like to know how much water you're applying as a depth of water. Does everybody because like you're saying in Iceland, water's not really a big issue because there's so much of it. So do golf course superintendents think of water in time or in millimeters?
I've often come into the and seen the setup of their irrigation systems, and they're obviously not. They're very poorly set up. Usually just on standard minutes, and the sprinklers one might be at 360, one might be at 180 degrees, still running at the same minutes. And so I've been sometimes coming in and helping guys out setting up their irrigation systems more accurately. And often it comes down to also poor installation where people haven't taken the time to make sure that sprinkler spacing is correct. Just throw sprinklers down in convenient places instead of, what's the most accurate way to place them, accurate nozzle selections and stuff like that. But I think we're sort of educating people. People are getting better. I'm actually heading off to the north to help guys out with their irrigation system now later this next week. So people are getting more and more aware of this. Even though we here in Iceland have abundance of water, nevertheless, we shouldn't be. There's no point in being applying too much water.
Yeah, you have an abundance of electricity also.
Yes. Yeah.
But it's not free. And
yeah, and I mean, if everyone uses unbelievable amount of electricity, then we need to create more dams or drill for more geothermal hot springs and stuff like that instead of just not doing it. And it's cheaper for society if we utilize everything that we have as well as we possibly can. That's just it's good for everyone if we do that. So therefore, even though I can access a lot of water, I should not be using that water if I don't need it. And from an agronomic standpoint too, it's better to keep your grasses at the sort of ideal moisture levels, not over applying it.
Yeah, I guess. Yeah, my interest in this is often related to having the best grass conditions. So we're talking here about the combination of playing conditions and healthy grass. That's the way we want it. And to do that, we need to make sure that there's the right amount of water in the soil. And to make sure that there's the right amount of water in the soil, we need to apply the right amount as irrigation. And I
And
think
using the metrics makes this so easy thought process because you head out with your TDR, get your percentage.
well,
I need to add that much percentage. What is that? That's actually in millimeters. I can, I can transfer that, and it's the same number.
let's
I'm not changing numbers using constants to change.
let's close with this, Bjarni.
Yep.
Let's explain again how that conversion goes for those who are not familiar with it. So we've got 1 square meter, and you grew up natively with this. So correct me if I'm wrong, or do you want to explain it? Why don't
you go ahead? I'll double check, but you actually do explain this quite well.
Okay. So we've got 1 square meter. It's kind of like 1 square yard. Okay. So, it's 1 square meter, and that area is the area on the surface, and we've got grass growing in it. But if we go down 4 inches, which is about the depth of a root zone, 4 inches happens to be 10 centimeters. So if we go down the 4-inch depth, or 10 centimeters, it works out that we now have 100 centimeters by 100 centimeters by 10 centimeter depth. That is 100,000 cubic centimeters, or 100 liters in volume, which is very convenient. So now we're dealing with a volume of soil, and that soil volume that we're considering is 1 square meter, which is about 1 square yard, down to a depth of about 4 inches, but it's 10 centimeters. Okay. So that soil, it has a volume of 100 liters, which is really good because 100 is like what percent is based on. So we can express in units of percent. So now if we have 10% volumetric water content, the VWC that you see with a soil moisture meter, that is volumetric water content. That is the volume of water in the soil per volume of soil. So if you have 10% water on, and that's what you measure with a soil moisture meter, that means if we're dealing with a volume of 100 liters, which we just said 1 square meter to a depth of 10 centimeters is, we now know that 10% water in that amount of soil is 10 liters of water that's present there. And then the convenient thing is, if you spread water at the surface, it turns out that in 1 square meter, 1 liter of water spread over the surface is exactly 1 millimeter in depth. So now we can start talking about evapotranspiration or talking about precipitation rates. 1 gallon of water would be 3.785 millimeters. So 1 gallon of water spread over that 1 square meter would be almost 4 millimeters of water, which would be
as long as that's a US gallon, because if it's a UK gallon, it's 4.8. So
so I'm only familiar with US customary
units. I had this argument in the UK with a guy. We realized halfway through the conversation we were both right, but both wrong.
So I was talking about US gallons there.
Yeah, US gallons,
and I would encourage people who do irrigation and have to apply water frequently, or you can still stick with the regular units that you like, but just use this particular hack, because for every 1%, so every 1% of water that leaves the soil, so if you go from 12% down to 11%, you've just lost 1 millimeter. So your if you've got a quarter inch, if your evapotranspiration rate is a quarter inch, then that would be 6 millimeters. And so you could expect that your soil moisture content would go down from about 18% down to 12% in a day in which you used the ET. In fact, I have a couple recent blog posts in which I talk about figuring out your actual site-specific ET and your site-specific crop coefficient, which you can figure out because ET is the results of an equation. But if you just go and measure the difference in soil moisture content, you're actually able to measure how much water actually was lost from the system. And so that's a few numbers. There's the cat again, and I would encourage anybody, you can catch this on YouTube or listen to it. It's good fun either way.
His name is Frodi. Try to say that.
Frodi.
Frodi. There we
Frodi.
go.
Well, is that a house cat or a work cat?
Oh, this guy runs the show in the neighborhood, I'll tell you. No, he's not a hunting cat, this one. He tries to catch the flies. That's about his hunting skills. He's got a brother who's a bit more of a hunter than him. But
Okay, good. So did I miss anything with the
no,
ease of that? Yeah, so
it is so easy to set up, and also if you're running irrigation, well, I'm used to the rainbird systems. It's so easy to just take the box up to the top, given that you set up your system correctly. Just take the box up to the top, apply 6 millimeters, and boom, off you go.
Yeah.
If that's your number that you want to, apply.
Well,
so
that's
it's
good.
so easy.
I would encourage people to play with that a little bit. It's fun. It's fun to know how much water you're putting. So you've got the efficiency issue, but you've also got the optimizing playability, making the grass as healthy as possible. Wherever you are in the world, you have a limited growing season. Even in Thailand, where it's really warm, there's a large part of the year where it's rainy and not really ideal growing weather. So there's certain times of the year that are better than others. And whether you're in Florida, California, New Zealand, South Africa, wherever you are, there's some times of the year that are better than others for growing the grass well. And when you have traffic across the grass, you need to make sure that you take advantage of those good times of the year. So things like getting the water right, getting the nitrogen right, making sure there's no deficiencies of other nutrients, and then checking the growth rate, and then making further adjustments. It's all related, and it's kind of like a modern way of greenkeeping that is a little bit related to math, or sometimes people talk about data. And the goal of this sub-series of ATC double cuts, this one was very broad, and I just wanted to introduce the topic and talk with Jason and Bjarni a little bit, and just talk about some of this stuff. But I think if we continue this series, which I think we will try to do, we will be a little bit more focused in the future episodes, and we'll say, okay, let's talk about something. So
you really narrowed it down there, didn't you?
well,
Yeah.
I was just thinking, okay, let's talk about mass balance for like nutrient inputs and nutrient harvest or something. But that's like really, really useful, because people might not realize that once we know the volume of soil, now if we know the bulk density of a sand root zone is 1.4, then we know that 100 liters of 1 square meter, it actually weighs 140 kilograms. So that's really convenient, because now we know the mass of our soil. And so now we know when we add the fertilizer, we know that as it spreads through that amount of soil, here's how much it's going to change the parts per million of nutrients in the soil, and various things like that. Also, as we harvest, so we can do these kind of mass balances. So that's the kind of thing I'm saying, okay, maybe sometime we dive into that as a specific topic, or just like the growth ratio, which, Jason's been using. The growth ratio is pretty cool, because it adjusts the clipping volume based on growth potential. So people often ask, how much should my grass be growing? And we say, it's normal to get about 10 milliliters per square meter per day, or something like that, if it's an active growing season. But then that depends on the time of year, because if it's November or December and you're far away from the equator, to the north of the equator, then it would not be common. And if you're in Tasmania right now in August, it would not be common to be getting that much growth. So it really depends. The growth ratio normalizes that based on site-specific temperature. So that's pretty cool. So there's I think for this to be listenable, and for it to be useful in any way, I think it will have to be focused, and we can't just jump around with numbers that we're familiar with. But
Yeah.
like if you said, okay, let's like start talking about pressure and bars in a 10-meter column of water, then you would lose me. And I think like, okay, I kind of know this, but I need to study it. So if we're going to do that, it needs to be an entire episode about, okay, explain to Micah how this works. So my idea is like, let's have some fun and share some of the things that are useful. And I don't know. So we'll do this some more. We're all busy. It's so hard to get these scheduled and to take time out of everybody's day to
we're in a few parts of the world, aren't we? There's we're going from morning hours to night times and everything. But we can do it.
Yeah, we can. So I'll be happy to hear feedback if anybody has listened to this, and so you kind of would get the idea of what we intend some turf math podcasts might be as part of this ATC double cut. So if you're watching or listening, I would be happy to hear from you if you think this is the most ridiculous idea you've ever heard and you're going to unsubscribe, or if it's something that you think, yeah, if you guys could just talk about something interesting, that might be good. So anyway, it's fun for us, and I kind of do this show because it's fun for me to have a chance to talk with people like Jason, who I thanked for being on the show earlier, and he had to go back to work. And it's such a treat for me to talk with you, Bjarni. We're about due for another meeting. Come to Finland in early November and join their greenkeepers meeting. I'll be there.
That's in November. I might actually do that.
I think it's November 1 and 2 or something like that. And yeah, I think there might be one in Paris also. I haven't announced that one yet. I need to check the details. I need to get my flights, but or maybe you could come to France.
This all sounds really good.
Yeah,
we can do a interrail.
Yeah,
travel down south. Yeah, it sounds good. No, I'll definitely have a look at that.
Good.
The Finnish guys are always doing some interesting stuff. So yeah.
Yeah, I'm interested. I've never been to Finland, so I'm interested to go there and learn from them. I learned so much from you and having a chance to see the grass in Iceland and learn about how it's managed and have that interesting long days, but the sun doesn't get very high.
Yeah.
So you can still have these
strange.
low ETs.
Yeah. Thanks for having me on. Really appreciate it. Always fun talking turf. That's
It certainly is. And to think that there's people around the world who are interested in turf to talk about these details like this. It's pretty cool. I mean, there's not a lot of us, but there's a few.
You sometimes feel alone in your corner and just like, am I the only one? But it's so good to sit down with someone and who enjoys talking turfgrass mathematics. Even that's great.
Well,
great
I think I can't remember whether it was you or Jason who first mentioned this to me, but it was sort of like a joke of like, wouldn't it be funny if we pulled up a spreadsheet and said, okay, let's talk about how we do some of this stuff, or let's just talk about like the topics that are math related. But actually, it's really about greenkeeping. It's about doing the greenkeeping job better, and maybe even, I don't want to say easier, but being maybe more
efficient. I think it's maybe
more efficient, maybe more in control. Because if you know exactly how much ammonium sulfate you put down, and you know what the growth potential is, and you know the weather forecast, and you know the clipping volume, all of a sudden, like you can, and if you know what your mineralization has the potential to be, all of a sudden you've got a lot of information.
Yeah.
And that actually it's just being comfortable with those numbers. It doesn't require much work. Because all those things they're just numbers. They're just numbers that you have. You know your fertilizer rate. the clipping volume you can get with a tiny bit of work.
Mm-hmm.
Yeah.
Still very, once you set things up, it's your staff actually does most of the work. So as in collecting the data, we just do it live. So I like to see it live coming in.
Mm-hmm.
So you can spot numbers if there are odd numbers coming out or whatever. So that's why I make them input it after every single green on their phone. But I'm just looking at numbers. I don't have to do much more. It's very easy. It's super easy. And people have sort of managed to get into doing this. They always find this is a way easier way to do greenkeeping than what they did before, because it was a more of a trial error sort of approach, throwing out stuff. Oh, that's too much, instead of being more accurate with what you're doing. So I think it's an easier way to do greenkeeping. By measuring.
There's a lot of different ways to do greenkeeping.
Yeah.
And I think this is an easier way too. And I think it's a way for continuous improvement, because you're constantly able to look forward and say, okay, let's adjust these numbers like this. And then you can check it against, it's calibrated against something that you've already done, basically. But that's not to say that you can't get great results doing it in other ways. But if you're interested in this kind of stuff, stay tuned to the ATC Double Cut, because we're going to keep sharing this kind of information. All right. Well, thank you, Bjarni. Thanks for joining. Thank you for your insight, and thanks everyone for listening. And
thanks for having me.
We'll be back. I will sign off now for ATC from Trang, Thailand. I am Micah Woods. Bye-bye.